Hello everyone, thank you for taking the time to view presentation. Today I will be discuss the concept of recoverability in database transaction in the database management system. Today, thank you for giving opportunity. I am Santosh from C section, second year. I want to explain about explaining the concepts of recoverability in database transaction. We have to know what is introduction to recoverability. Recoverability is a fundamental concept in database transaction that ensures the integrity and consistency of data. We want to have a database which we requiring consistency of data. Without consistency of data, the information goes wrong. It involves a mechanism that allows a database to restore its state after a failure or crash. It means any errors are going or any interruptions are in data. It takes a restoring of data. Understanding recoverability is essential for designing robust and database system that can handle unaccepted errors. We have a errors that are which we can't able to transact it. After that, we have to learn about what is database transaction. It is a transaction which performs operation as a single logic unit of work. Basically, being a transaction first active state if is done partially committed and committed. Otherwise, it may be permitted to fail or to activate. For example, if is the activated partially committed to failed, or we here have to explain about here where active is done after if it is partially going on, after that it coming to committed or committed, it is final transaction. In case the case in partial case is any aborts or any delay is going on, it gets to failed, then it go terminate and again reprocess it. Okay, this is the main topic. And transaction must either to asset properties. The asset denotes atomicity, consistency, isolation, and durability. Atomicity is it means it dividing the solution into multiple wards and individual pods, and finally we merging the finally the problems are where are existed these are merged and it makes very easily. The word aramicid, it is individual pieces or individual subparts of database. Consistency, here is consistency tells about where information is how accurate or how redundancy is that. And isolation is simply which how isolating the problem in easy manner. And durability, which accessing the values are easily. These properties ensure that transactions are the processed reliably, preserving data integrity. After that, yes, some are the important recoverability where application is done by the watchdog, and some are the configurations and configuration manager system with the VM backup, and again spare spot by hardware server, and data replication by data center, and disaster recovery by region. These are the main parts are important in recoverability where application application performs this quality. And after that, types of failures. Failures in a database can arise from various sources, including hardware malfunctions and software bugs. Understanding the types of failures help in designing effective recovery. The word that comes effectively, effectively recover. Where failures are perfect and types of helps in recovering the mechanism. The main category including transaction failure, system crashes, it and media failures. For example, failures are three types where transaction failure and system failure and data transfer failure. In case transaction failure, there are logical error, system error. In case system crash done in forgot or malfunctions and bugs in software and OS. Any problems are arise in software system or a system software or any uh, Linux problem or any Windows problem, that is OS, that means operating system. After that data transmission, it may leads to disk head collapse and disk unreading information, formation of some other um, magnet tapes, which problem in a data transfer in a secondary memory. After that, transactions there are transactions there which can several states that actively, partially committed, fail and abort. We discussed already in first case. Active state where active state goes to partially. After that, partially completed state mm, performs complete state. After that, terminates if any problem. Stores in this process partially committed to state and committed state. This is main process is permanent store, which performs in case of any problems occurred. Then here partialities again it causing to failure. Failure state may be recover rollback. It is main important in transaction. Will roll back the every information and from original state. In case failure main state is okay. This is the state of transaction determines how it will handle during the recovery. Knowing these states vital for implementing recovery strategies effectively. After that, undo and redo operations. When undo operations are retrieved changes made by transactions that have been failed, redo operation is to reapplying the changes made by the committed transaction that were lost due to crash. Both operations are key components recovery algorithms and database system. First of all, here undo is retrieving wherever the data is information or for example having A is 500, B is 1000. If I want to transfer B amount into A, it maybe uh, takes some time. It take for example A having 500 and B 1000. It transfers A having 1000, B having 500. In case there is no any gap or any difference between both members, it maybe we apply undo either or redo. In case we complete to undo, the complete information come back. Otherwise, we're again reapplying the problem. Control Y in similar to in Excel or in any PowerPoints. Okay. After that, log-based recovery is one of the best method to approach transactional logs to update or commit our data or database. For example, log-based recovery is a common approach that makes us the transaction logs to maintain recoverability, and the transaction log records all changes made to database, providing a history that can be referenced during recovery. This method supports both an undo and redo operations in enhancing database resilience. After the checkpoints, what are the checkpoints used? Checkpoints provide precise reference points for measuring project status. And again, the software development process further extend the checkpoints idea from a few points to all processing phases. Each phase produces a specific result, and hence completion of phase is measurable in checkpoints. These are the main important points. They serve as a reference point that can be expanded recovery process by reducing amount log data need to process where the information stored in this. After that, distributing transaction, how going transaction going to be distributed in distribution database system. Transaction may multiple sites or database. Recoverability in distributed transaction requires coordinate among different nodes of ensure consistency. Protocols such as two-phase 2pc are often used to manage complexity of distributed recoverability. After that, these are two phases: flat transaction, nested transaction. After the challenges what are we face in real estate, implementing standard operation and the occurrence of disaster and failure, interruption and disaster failure to extend operation, clearance of disaster managed by recovery process, restoring all process. Additionally, the designing of recovery in distributed system added complex to recovery process. After that, we are studying about real cases in what our recovery is going on. For example, analyzing real scenarios can provide insight into importance of recoverability. Case studies often highlight the impact of failure on business operations and the effectiveness of recovery strategies. Learning from these case helps to organize better preparation of potential data loss situation. For example, prepare work and outlining case and completing the analysis. These are the after that. mm, Finally, we observe that finally what is recoverability is database transaction managed that safeguard data integrity. With data transaction done in safe way and effectively without losing data. Finally, we understood that technology or stating information about best practices in recoverability remains essential for data professionals.